ございます。私はアーロンです。どうぞよろしく。1年間くらい日本語を勉強していました。ありがとう、ありがとう。でも、心配しているから英語を話します。My name's Aaron Patterson. I am from Seattle, and I have not met Ichiro. So my first slide is some America studying that you should do for my presentation. The third link is a PDF of the presentation if you'd like a copy. My talk is titled Blurring the Language Barrier, but first I'd like to talk about language bending. Now, language bending is something that we do every day. We integrate Ruby with Java to write Java programs in Ruby. We write new languages, like domain-specific languages using Ruby. We might change our language because it doesn't have the libraries we need, or maybe the language is missing something. But these techniques aren't limited to just Ruby. Specifically, I want to talk about JavaScript. First, I'd like to show a couple of examples of JavaScript bending, and then I hope to explain why they pertain to us as Ruby developers. For example, this is BDD testing in JavaScript, like RSpec style testing using JavaScript. So this particular JavaScript shows how it can be extended to give us RSpec style tests, or even enumerations. The prototype.js library adds enumerations to JavaScript so that we can have an each function. Above the JavaScript is the Ruby equivalent. Unfortunately, the JavaScript doesn't look exactly the same as the Ruby. There's still this anonymous function, and it just doesn't look exactly the same. We seem to have an impedance mismatch. JavaScript and the Ruby are not quite the same. I want to get them to be as similar as possible. Can we correct this? I'm not quite sure if we can correct it, but I think we can find out by playing with Johnson. Johnson is a Ruby wrapper for SpiderMonkey. SpiderMonkey is Mozilla's JavaScript interpreter. Johnson exposes an interface to the interpreter and also provides JavaScript extensions. We're going to be looking at the features that this library provides, and first we'll start with the parser. So Johnson provides an interface to the parser that is in SpiderMonkey. The interface is quite simple. It just takes a string of JavaScript and returns to you an abstract syntax tree. You can manipulate the abstract syntax tree, and Johnson provides a few methods for manipulating it. And we're going to look at these particular methods. The first one is toSexp. toSexp returns S expressions of the parse tree. So if you want to get a quick visual representation of the JavaScript parse tree, just call toSexp and you'll get a large S expression back. Also is the toDot method. toDot turns your AST into a dot file, which is suitable for displaying in GraphViz. So if you'd like a visual representation of your parse tree, you can output a dot file. This example shows a function which calculates the Fibonacci sequence and outputs the parse tree as a dots file. Once you save the dots file, you can look at it in GraphViz, and this is actually a representation of that parse tree. Also is toECMA. toECMA will take your parse tree and turn it back into JavaScript. If you modify your AST, you can take the modified AST and turn it back into JavaScript. Johnson implements a visitor pattern, so if you'd like to walk each node of the parse tree, you can implement a visitor. But that might be too difficult, so I've also provided an each method. This lets you iterate over each of the nodes in the AST. So this particular example takes all values that are equal to n and changes them to hello, and outputs the JavaScript again. This is kind of interesting for doing AOP-style programming. So you can do aspect-oriented programming. For example, taking point cuts and introducing maybe a logger into your JavaScript. The parser also exposes syntax errors. So if you have a syntax error in your JavaScript, you can detect that. It will throw a syntax error, and you can see what it is. So now I would like to show you the interpreter, at least the interpreter interface. Johnson provides a bridge between Ruby and JavaScript, and I would like to look at that bridge. The bridge lets you move an object from JavaScript over into Ruby or from Ruby back over into JavaScript. The way that we handle this are two proxies, a JavaScript proxy and a Ruby proxy. And I'd like to look at these proxies a little bit more in depth. This is the Ruby proxy. When transferring objects from JavaScript into the Ruby runtime, it automatically wraps the objects and gives them to the Ruby runtime. So, this example shows a JavaScript object being declared in JavaScript, pulling it into the Ruby environment, and then manipulating it. All methods are transparently proxied for you, so there's no way for you to tell that this is even a JavaScript object. Now we have the JavaScript proxy, which looks almost exactly the same as the Ruby proxy. The Johnson runtime can be treated as a hash, so you just assign your variable into the hash, and it's available inside the JavaScript runtime. So everything is automatically proxied for you, and it just works. Now let's take a look at some proxy abuse. The first thing I'd like to show you is pulling a JavaScript object into the Ruby runtime. This example shows the instantiation of a runtime and evaluates a JavaScript array. The last thing evaluated in the runtime is returned and proxied to Ruby. And then we just iterate over each of the elements in the array and print them out. And as far as the Ruby interpreter is concerned, this is just a regular array, even though it was implemented in JavaScript. Even lambdas can be passed back and forth. So this example shows pulling an anonymous function out of JavaScript. That anonymous function can then be used as a lambda in Ruby. So this shows each array element being multiplied by 2 and then printed out. We can even do object definition in JavaScript. So we define an object in JavaScript and return it, and we can call methods on it. Iteration is also possible. So far, we've only seen examples of pulling objects out of the JavaScript runtime. And I'd like to show you putting objects back into the JavaScript runtime. This example shows an object called RB_obj being defined in the runtime. So we just give the runtime our array, and it's automatically into the JavaScript runtime, wrapped and usable. this array can be treated just like any JavaScript array, even though it was defined in Ruby. We can even mix object definitions. So in here, we're assigning a new method to the object defined in Ruby. We instantiate an object in Ruby, put it into the JavaScript runtime, and then define the awesome method on the Ruby object. So the awesome method gets defined, and back over in our Ruby runtime, it can be called just as if it was defined in Ruby. This just works. This can refer to self, so this is context aware and works just as it should. So next I'd like to take a look at some of the JavaScript extensions that Johnson provides. We've added a few extensions to help us with development. And we're trying to keep most of our development done in either Ruby or JavaScript. So the first extension I'd like to take a look at is Johnson.require. This works exactly like Ruby's require, in that it searches your load path for a JavaScript file and then evaluates that JavaScript file within your runtime. So this looks for a Johnson/browser.js, and if it can find that file, evaluates it in your runtime. Ruby constants are available to you in your runtime. So this lets you output or use any method that's defined in Ruby. Right here, we're outputting the current Johnson version that we're using. This means that anything available to you in Ruby is also available to you in JavaScript. For example, in here we're using threads. We've been able to just access Ruby's threads and create a new JavaScript thread. And everything works. New just works. You can instantiate a new Ruby object in JavaScript using JavaScript's new notation. In the previous slide, I showed calling .new as a normal Ruby method, but in this one, we're using the new constructor. One last extension that I'd like to show you is EJS. Johnson includes an ERB-style parser that's written in pure JavaScript. And we've added a Rails plugin that works with Edge Rails and lets you write your Rails views in JavaScript. And if I have enough time, I will show you an example that works. We also have Bin Johnson, which is similar to IRB, but gives you a JavaScript and a Ruby interactive shell. So you can switch between your JavaScript shell and your Ruby shell. Now I'd like to talk about the future. We haven't released Johnson yet, and I want to talk about what we are trying to accomplish before we do a first release. We'd like to add a better interface for aspect-oriented programming. It is not very easy to set point cuts yet, but I would like to make it easier. JavaScript testing. Currently, when writing your Rails apps, I bet that none of you test your JavaScript. Or if you do, it's done with something like Selenium IDE. It can't be done on the command line. What we want to do is get a fully working command line integrated way to test your JavaScript. So that means getting a document object model, which is the only thing holding us up. Once we get a fully working document object model, we can test your JavaScript manipulations of your views. Currently, both jQuery and Prototype work in Johnson. It's just the document object model that is not working. Also, I would like to integrate this with Mechanize, which means that you should be able to write scripts that interact with websites that use JavaScript. And finally, optimizing your Ruby. Some things the SpiderMonkey interpreter can do faster than Ruby, and if you would like to increase your performance, you may implement them in JavaScript. And as you can see here, Ruby performs way under JavaScript. This is a joke. Usootsuku. Anyway, this is the Johnson team. John, me, Yehuda, and Matthew Draper. And if you'd like to see more info, go here, these URLs. And I think we have plenty of time left, so I'm going to show a few examples of it actually working, and then take some questions. So, Still too big. All right, is that big enough? Everyone can see? Let me switch views here. So the first thing I'd like to show is I implemented breakpoints on the airplane, and that didn't make it into the slides. Here in this example, we're pre-compiling a JavaScript script and then setting a breakpoint on my script on line 3. And when that breakpoint gets hit, the Ruby block gets executed. So we're iterating over from 0 to 10 and increasing I by 1 and increasing X by 2. And then we evaluate the script. So each iteration through here, this block will get called. Okay, I will show that now. So each of those got hit. It works. Right here, we're indexing into the Ruby runtime, or the JavaScript runtime, pulling out the I variables and the X variables. Next, I will show you the interactive shell. So right now, when it says JS, you're in the JavaScript interpreter. You can switch over to the Ruby interpreter by doing RB. So back in the JavaScript interpreter, we'll make a variable called foo, set it equal to bar, and back over in the Ruby interpreter, we can say JS sub foo and get the string back. We can even assign lambdas, so we'll do JS sub sum equals lambda x plus y. Switch back over to the JavaScript interpreter and do sum of 10 and 20. So it called back out to the Ruby Lambda to sum the variables and then automatically put it back into the JavaScript interpreter. What else do I want to show you? I made a list. Yes. So we have a partially implemented DOM with jQuery working. And I would like to show you an example of that. Need this. I can't remember the file location, and I don't want to type it. Now we might have to wait for a minute because setting window.location is a threaded operation and takes a second. I don't know why exactly, but it does. There we go. So it successfully set the location, and now we can access things on the document. So I can say, like, let me look up my example. Oh, first we'll require jQuery. Does anyone here use jQuery? Prototype? All right. We'll load in jQuery and then access all of the H1s. I guess there are no H1s. How about all the Ps? So we've been able to get back a list of all the Ps in the HTML file. Now what this means is that once we get the document object model improved, we can start testing all of your JavaScript code. Let's set that equal to a variable. Can head back over into the Ruby land and say JS sub PS and get back our list of Ps. So there are our P nodes. What else do I want to show you? Ah, yes, get element by ID. I like that. We're able to access the document straight out of the JavaScript runtime and get an element by ID. So it's completely proxied and everything just works. And finally I'll show you the Rails example. So I've got a simple Rails application set up here. It just has a database with one table of users, just has a few users in it. So we can do, got a list of users in the database, and one controller, the users controller, that just finds all the users in the database. So very simple, but the view is written in JavaScript. So we're able to pull out all of the users using the special @ variable, @users, and iterate over them in JavaScript. So I will start up the server. And those are pulled straight out of the database, iterated over using JavaScript. And we can view the page source here, so you can see, in fact, it is evaluated on the server side. Why did we do that? Because I could. All right, any questions? 質問がありますか? None. Okay. Yes. 日本語でもいいです. Thank you. Yes, I like Japanese a lot. I'll continue to study when I get home.
ドムの操作をやってたと思うんですけど、レオ、ドムの操作はスパイダーモンキーの中でやってるのか、ジョンソンの方でやってるのか、どっちですか？
Oh man, わからない。So
when you're manipulating the DOM,
Yes.
do you do it inside SpiderMonkey or inside Johnson?
When we manipulate the DOM, it's done completely inside of SpiderMonkey. So it may call out back and forth to Ruby depending on the implementation, but we've written, the DOM parser that we have right now is written completely in JavaScript, so it is done all inside of SpiderMonkey.
はい。すべての操作が JavaScript で書かれてて、SpiderMonkey の中で行われているということです。他に質問ありますか？
Thank you for your very interesting presentation. ちょっと英語の勉強させてください。I'm just wondering, so is there any real application using this Johnson?
Currently in use?
Yeah, in use, yes.
Not well. There is one. One of our team members in Australia uses it. I'm not sure exactly what he uses it for. I think it's a JavaScript, some sort of JavaScript application server where they have many developers running JavaScript, and you can customize your app using JavaScript, and then he pulls that into Ruby and executes it. So I won't be using it until we get the DOM completely finished.
現在、ジョンソンを使っているアプリは、稼働しているアプリはありませんが、オーストラリアにいる同僚が、ジョンソンを使っているアプリを作っていますが、だけど、ドンも完成するまでには多分使われないだろうなと言ってました。
Can I another question? So why did you develop this application? Just for fun?
Just for what?
Why?
Oh, why?
Just for fun. Just for fun.
Yes. I developed this application in my free time for fun, but the main reason that I started doing it was to give mechanized JavaScript support, because nobody does that yet, and I wanted to be able to interact with websites that use JavaScript.
主に趣味で作ってましたが、もう一つの目的は、メカナイズに JavaScript 対応したいんで、JavaScript を使っているサイトでもメカナイズで、操作できるようにしたいと思いしましたので作りました。はい、
Thank you very much.
You're welcome. All right. Nothing else? Okay. Thank you very much. どうもありがとう。